All right, we're on the 2.5 Ready, Set, Go Mathematics Vision Project. Please make sure you've put your name at the top and your period number and date. The first section is asking you to recognize quadratic equations, identify whether each equation is quadratic or not, and explain how you knew. So looking at the first one, what do you think? See that little x squared? So yes, it's quadratic because it has that power of 2. Or you could say an x squared. Okay, next one, what do you think? The next one's kind of sneaky. If I minus 3x squareds from both sides, those would actually go away, and it just leaves you x. So this one is not quadratic. It's very sneaky, very sneaky. And the justification is because the x squareds cancel out and leave a plain x. So what does that make this? It makes this one linear. Who knew? Okay, next one has an x times a 4x, which gives us 4x squared, and then x times negative 5. So again, if I multiply this, then I can see that squared, so it is quadratic. Justification is after we multiply, we can see the squared. Or something along those lines. All right, next one, is it quadratic or no? Well, there's 2x's plus 6x's, which is 8x's. And that's not multiplying, it's just adding. So it is not. This one is linear because it has x to the power of 1, not x squared. All right, the next one, is it quadratic? Does it have an x squared? No, it has a power of x instead of a power of 2, which is exponential. And finally, this one does say 4x squared, so it is quadratic because of that power of 2. How'd you do? All right, next we need to do some work on these so that we can change them into vertex form, making it easy to graph. So step 1 is bump that 1 over, making space. Step 2 is the B work. Half of negative 4 squared is negative 2 squared. Negative 2 squared is 4. I'm going to add 4 and subtract 4 to balance. That gives me the x minus 2 squared from this. And then 1 minus 4 is negative 3. Now I can see that my vertex is at 2, negative 3. This is going to be an upwards orientation of parent stretch. Out 1, up 1, out 2, up 4. So let's go make our graph. I'm going to make this go up 1 higher because of the vertex. All right, so putting a dot at 2, negative 3. 1, 2, 3, 4, 5. All right, 2, negative 3, that's my vertex, and then counting the parent stretch up. Out 1, up 1. Out 2, up 4. Out 3, up 9. And you probably could even fit 416. I didn't check. Depends on how you scaled. Okay, so we had to first convert it into vertex form, and then we were able to graph it. How'd you do? All right, pause the video and try this next one on your own. See how you do. All right, step 1 is make space, bump that 5 over. Step 2 is the B work. 2 divided by 2 is 1 squared. Add 1 and subtract 1. This is the x plus 1 squared perfect. 5 minus 1 is 4. And then my vertex is negative 1, 4. Go ahead and graph it. Label and scale your graph. Okay. Go put a dot at the vertex, at back 1 up 4. And then this one is also parent stretch, out 1 up 1, out 2, up 4, out 3, up 9. Let me double check my counting. 1, 1, 4, 9. Connect it. And then last thing on both of these would be to put in your lines of symmetry straight down the middle, and label them. This one has a line of symmetry through x equals 2, and this one has a line of symmetry through x equals negative 1.